Okay, so the second part of the lesson here in simplifying irrational expressions. Same rules apply, we're just going to make it more complex. So remember the rules from yesterday? You can only reduce a monomial with a monomial, a binomial with a binomial, trinomial with trinomial. All right, and remember that binomials can only cancel if they are identical. So let's just begin with our first example. If I have, first example here, if I have 3x plus 15 over 2x squared plus 10x. All right, so remember, we cannot just come in here and start canceling out the individual terms. This is a binomial on top, this is a binomial on the bottom. You're never allowed to just take pieces of the binomial apart. Either the entire binomial cancels or nothing at all. So right now, the one on top is not identical to the one on the bottom, can't cancel anything. First step is always going to be factor. So let's take a look at the top first. Looking at just the top, let's go ahead and factor that guy. So I could take out a 3. So that would be 3x plus 5. Now, looking at the bottom, what can we take out? These can both be divided by 2, and I can take out an x. Take a 2 out of here, I'm left with just x. Take a 2, take a 2x out of here, and I'm left with x. Take a 2x out of here, and I'm left with plus 5. Now, I can see that my monomials are not the same, and there's nothing in common here. There's nothing in my monomials that I can cancel, but my two binomials are now identical. So I can go ahead and cross those two guys off, leaving me a final answer of just 3 over 2x. Go to the next one here, number 2. So let's say we've got 4x cubed minus 8x squared all over x cubed minus 4x. So on the top, I can take out, again, start by factoring. So we're going to factor the top. I can take a 4 and an x squared out. So 4x squared. Take a 4x squared out of here, I'm left with just x. Take a 4x squared out of here, I'm left with minus 2. Now the next one, on the bottom here, I can take out an x. So if I take out the x, I'm going to be left with x squared minus 4. Now, we're not finished on the bottom here. Remember, whenever you have a binomial that is a perfect square minus a perfect square, you can break it into 2 more binomials. Hence, this guy, I can break this into x plus 2 and x minus 2. So that's what we're going to do. So let's erase that. You write x plus 2, x minus 2. And now let's see what we can cancel. If I look at my binomials first, I know I can cancel the x minus 2 and the x minus 2. So those 2 are gone. If I look at my monomials in front, my x here can cancel one of my x's up here. So I can cancel this guy out and subtract 1 from this. So then that's going to give me an answer of 4x over x plus 2. And so all of this simplifies down to that. And that's as far as you can go. Remember, you can't cancel the 4 and the 2 because this is a monomial and this is a binomial. And we can't cancel those 2 together. So that you can't cancel the 4 with the 2, you can't cancel the x's. This is as far as it goes. Go over another example. If I have 8x squared minus 24x all over 6x cubed plus 6x squared. Example number 3. All right, so let's begin. Factor the top first. On the top, I can take out an 8 and I can take out an x. So if I take out the 8 and the x, I'm left with x minus 3. On the bottom, I can take out a 6 and I can take out an x squared. So take out the 6x squared. Take a 6x squared out of here, I'm left with x. Take a 6x squared out of here, I'm left with just +1. All right. Now, I can see my binomials are not the same. So the binomials are not going to cancel. Let's look at my monomials. The 8 and the 6 can be reduced. This would become a 3. And this would become a 2. And then this x will cancel, and I can subtract it from here. So on the top, I'm left with 3x minus 3 over 2x x plus 1. And that would be it. That's as much as we can cancel. Another example. If I have x squared plus x minus 12 all over 5x plus 20. All right, so start with the top first. And this guy we can factor. So we can either use the shortcut or by grouping. I'll do it by grouping in case that's the way you're comfortable with. I'd first multiply 1 times 12. That makes 12. Then I need two numbers that will subtract to give me a 1. So that's going to be 4 and 3. So I'll need a positive 4 and a negative 3. So I'm going to have x squared minus 3x plus 4x minus 12. That's going to give me x times x minus 3 plus 4 times x minus 3. So this guy is going to factor down into x plus 4 and x minus 3. And then on the bottom, we have a 5x plus 20. So I can take a 5 out of each of these. So if I take out the 5, that gives me x plus 4. So now I can see that I have two binomials that are going to cancel out. So cancel that, and I'm only left with x minus 3 over 5. One last example. So let's say we've got 3x squared minus 5x minus 2 all over 18x cubed minus 2x. All right, so factor the top first. There's no common factor to take out, so we're just going to go ahead and try to do this by grouping. So 3 times 2, that gives me 6. I need 2 now. Make sure you pay attention. I need two numbers that are going to subtract to make a 5. So I can't use 3 and 2. I'll use 1 and 6. And I need to get a negative 5, so that's a negative 6, positive 1. So I'll have 3x squared minus 6x plus 1x minus 2. So I can take out the 3 and the x, leaving me with x minus 2. And then there's nothing in common here, so I'm just going to put a plus 1 and x minus 2. So this guy factors into 3x plus 1. And then x minus 2. On the bottom, I can factor out a 2 and an x. So 2x, leaving me with 9x squared minus 1. And since this is a perfect square minus a perfect square, I can factor this down further into 3x plus 1, 3x minus 1. So let's change that. And so now I can go ahead, cancel this with this, and there's nothing else I can cancel. So I'm left with x minus 2 over 2x, 3x minus 1, and there's my final answer.